Hi, today we're going to look at Unit 15.3, Day 2, Operations with Radicals. As a review, let's look at when a radical is in simplest form. There are no perfect squares, no perfect cubes, etc., other than 1 in the radicand. There are no fractions in the radicand, and no radicals appear in the denominator of a fraction. Let's look at some examples now. Alright, the instructions are simplify the radical expression completely. Number 1, the square root of 7 times the square root of 14. First thing I'm going to do, bring the two square roots together. So square root of 7 times 14. I'm going to do a factor tree, breaking into prime parts. 7, 14, 7 times 2. Your index, remember, is here. The invisible 2, so square root. So we have a pair of 7s times the square root of 2. Example 2. 1/2 times the square root of 100 times 3 square roots of 9. We have some perfect squares with this problem. The square root of 100 is 10. Square root of 9 is 3. So I brought down the 1/2. Square root of 100 is 10. Brought the 3 down. Square root of 9 is 3. Simplifying, 1/2 times 10, 1/2 of 10 is 5. 3 times 3 is 9. 5 times 9 is 45. Let's begin to look at some problems with variables now. Number 3. Negative square roots of 3x times 4 square roots of x. If you have a negative with no number, remember that's negative 1. I'll just rewrite the rest of this. I'm going to bring the coefficients together by multiplying. Negative 1 times 4 is negative 4. I'm going to bring the two radicands together. 3 times x times x. Your index is 2, so we have a pair of x's that can come out. So negative 4, bring out the x, and you're left with square roots of 3. Number 4. Negative 2 square roots 7xy squared times 3 square roots of x. I'll bring the coefficients together by multiplying. Negative 2 times 3 is negative 6. I'm going to bring the two radicands together. 7 times x, y squared, y times y, times this x. Form your pairs. You have a pair of x's that can come out and a pair of y's that get to come out. So negative 6, write your variables in alphabetic order. x, y, and we're left with the square root of 7. Number 5. Two square roots of 6x squared. And I'm going to show you how to do this one two ways. Method 1. We can write the part that's in parentheses down 2 times because of exponent 2. Multiplying your coefficients, 2 times 2, 6x and 6x. Break down the 6, 2 and 3. Break down the other 6. You have x and x. And form your groups. You have a pair of 2's, that's going to come out with the 4. You have a pair of 3's that are going to come out, and a pair of x's. Nothing is left underneath the radical. So 4 times 2 is 8, times 3 is 24, times x, 24x. Another way to simplify this problem, method 2, using what we know about exponents. Everything inside gets raised to the second power. So 2 squared times the square root of 6x squared. 2 squared is 4. When you square a square root, you just have the radicand. When you square a square root, you just have the radicand. 4 times 6x is 24x. Number 6, distributing negative square root of 3 times the sum of 2 plus the square root of 12. So if we distribute coefficient, radical, negative times 2 is negative 2, square roots of 3, negative times a positive is negative, 3 times 12 is the square root of 36, square root of 36 is a perfect square of 6, so negative 2 square roots of 3 minus 6. You could have also done this part, the square root of 36, as negative 3 times 12 and broken it down into its prime parts, and just continue doing that. Alright. Number 7, let's look at some division problems. Suppose we are dividing square root 7 divided by x squared. Sometimes it's best to take the entire radicand and break it down into 2 separate parts, because one of the rules states we cannot have a radical in the denominator. Square root of 7, you can't simplify anymore. X squared, you have x times x. You have a pair of x's that will come out. So square root of 7 divided by x. Number 8, square root of 18 divided by 3. This one we could simplify easier by keeping the fraction together. 18 divided by 3 is 6, and you cannot reduce the square root of 6. Number 9 is the longest problem we will do. Alright, we have 3 times the square root of 2x squared times square root of 8/25. I'm going to reduce what I can from each radical first. So 3 square roots of 2x squared. 2 you can't break down anymore. X squared, you could do x and x. So you have a pair of x's. So this will come out with the 3. So 3x square roots of 2. Alright, second radical. I'm going to separate the 8 and the 25, square root of 8 over square root of 25. Square root of 8, I'm not going to do anything with it just yet. Square root of 25 is a perfect square, 5. So what we have from the first radical is 3x square roots of 2 times from the second radical square root of 8 divided by 5. We can take the first expression and place it over 1. When you multiply two fractions, you multiply straight across, multiply the numerator. 3x, radicands, 2 times 8 is square root of 16. Denominators, 1 times 5. 3x. The square root of 16 is a perfect square. Square root of 16 is 4. Well, that's over 5. 3x times 4 is 12x divided by 5. If you have any questions, please email your teachers and let him or her know that you have questions. If I can do anything to help you, please let me know.